All right, guys, welcome back. So we're going to walk through experiment 3. I'm a little late on this, I apologize. But we're going to walk through experiment 3 and take a look at what this is talking about. This is about weak acid titrations. So we've been talking about weak acid titrations and what these look like and how they're different from what we've done in the past. So we don't have that same titration curve that we've seen previously. So we'll be looking at what these look like and how they're different than what we've talked about previously. So we are talking about a double displacement reaction. We form an ionic salt and water, of course. We can determine the properties of these materials because we form this buffer zone in here, the half equivalence point. So our equivalence point here in the center, which is above 7, because we're talking about a weak acid with a strong base, that the volume at the half equivalence point is where we have our pKa. Okay, and that point is very indicative of what that particular acid is. And so we can use that as a point to discover what that acid is, right? So a plot of the pH versus volume is very important to us to be able to determine what that is. So we can look at that. We can use that to compare against known weak acids to determine what we're looking at. So we're going to be reacting NaOH versus our generic HA to get that NaA plus H2O, where HA represents an unknown weak monoprotic acid. Okay. Remember, if we were dealing with a diprotic acid, we'd have 2 equivalence points that came into here. And so we'd see those 2 rises that we get from that. A triprotic acid would have 3 of them. And so you could identify based on that curve how many protons we were seeing. Okay. Titration of all weak acids with a strong base will have a modified S curve. So we'll have this buffer region underneath, this height right here, and it's going to be where that the pH of the equivalence point will be above 7 because it's a weak acid. Okay, so those are the kinds of things that we're going to be looking at. We can take a screenshot of this if we choose to do so that we have this information for later if we want or need it. I tend to do that just in case I want that while I'm working on my quiz. I don't know that it needs to be huge, but you know, there's what I've got. So I can just make that a little bit smaller. And then I can minimize that and move on to the simulation. Okay. Now we want to identify the equivalence point in the titration curve. In this particular curve, we're talking about D. So I'm going to scroll down to see those. So that is D, and we'll go on. So it says, yay, you know what you're doing. Awesome. We want to fill the burette with the 0.055 molar sodium hydroxide. So I don't necessarily know where we are. So this is my sodium hydroxide. So I can open it up and pour that in there. I need to scroll in a little bit. Oh, wait, I want to zoom in. So I know looking at my meniscus, I'm at 0.1, roughly 0.2. So I'm going to put that as 0.2. So my concentration, I'm going to look at it in just a second, 0.02. No, that's actually 0.2. This concentration, it gave me 0.055. That was on the bottle. I don't know what my concentration of my acid is yet. Oh, wait, it does tell me. It says 0.010, 0.10, but it's not going to let me write it down. Okay, awesome. So I'm going to scroll back out, put that back on there. So record concentration and initial burette volume in the lab data. I did that. Recap the Erlenmeyer flask. I did that. Use the volumetric pipette to add 10 milliliters of this guy right here to the clean Erlenmeyer flask. And I can put this in here. And then I need to record that in the data. So concentration 0.10. And I added exactly 10.00 milliliters because it's a graduated pipette. And it says that right there, 10.00. Okay. take that out. And I can go to the next phase because that's the last thing it says. Now it says remove chemicals for disposal and add a stir bar to my acid. And then place this under the bureau. I'm going to turn on the stir plate and get that lovely noise. And then I'm going to move the pH probe into here. Oh, wait, I got to clean it first. Clean that. And then position it here. I don't like the way they position that. I would never put it just like that. I always have something holding it. These things are really expensive, so I would never allow it to, one, touch that stir bar at the bottom. It'll damage it. And two, I would never just leave it hanging like that. You always hold it. So just now that I've said that, and we want to record the initial pH, which is 2.87. 2.87. Out of 7. That's a 7. Okay, fine. And now we can go to the next phase. Now what it's going to do is add approximately 1 ml and record the Bure volume. So I'm going to add a ml, and look at the volume, and it's 1.02. 1.20. Because I can wait. And I can zoom out. So we've recorded the volume, calculate and record the total volume of sodium hydroxide added in the lab data. Total volume added is 1.00, because it's the difference between those two. And then the pH at this point is 3.51 for that too. 3.51. Okay. And we're going to repeat that until I have added approximately 4 milliliters. And add one more. And zoom in. And you see that's 2.20. This is 2.20. That's going to give me 2.00. And I need to zoom out so that I can look at the pH. And that's 3.84. Add another milliliter. Zoom in to look at what this is, 3.20. 3.20. It gives me exactly 3 milliliters that I've added. Zoom out so I can look at 4.04. 4.04 is my pH. I'm going to add another milliliter. Look at this, 4.20. In the lab, this is never this easy. Zoom out again, and 4.20 is the pH that I'm looking at. Okay. I've done all of that with approximately 4 milliliters, so I can go into the next phase. How will I know I am approaching the equivalence point of the titration? pH of the solution will change by a large amount after the addition of a small amount of base. pH of the solution will change by a large amount after the addition of a large amount of base. pH of the solution will change by a small amount after the addition of a large amount of base. And the pH of the solution will remain constant. Well, it should change a large amount by the addition of a small amount. Hello? Yeah, but that's okay. Oh, dear. Okay, so like I said, that pH, we expect that to change a large amount when we add a small amount of that stuff. So we would expect that when we are near the equivalence point. So cool, we got that. Awesome. So now we're back here and we're going to be adding smaller amounts. So we're going to add approximately 0.5 mils to this, and then we're going to get our total volume, and that's going to auto-populate now, thank goodness, because we don't have to do it every time. And we're going to record the pH. So we're still recording the pH, so we're now at 4.26. Oh, didn't finish. We got to do that a couple more times. Now at 4.32. 4.38. 4. Now at 4. 4.59. 4.64. No huge changes yet. 4.69. Well, that's big. No, not yet. 4.74. Oop, too much. 4.78. 4.83. 0.88. 4.93. 4.98. 5.3. 5.9. 5.4. 5.20. 5.27. 5.34. 5.42. 5.1. 5.61. 5.4. 5.10. 6.15. 8.65. That's a bigger jump. 9.24. 9.65. 9.86. 10.00. 10.11. 10.19. 10.26. 10.32. 10.38. 10.42. 10.7. 10.51. 10.54. And 10.7. Of course, I know I'm done now because the little button has gone away. And we've gone at least 25 mils. So awesome. Now, one of the things I'm going to comment now, one of the things that I love about doing this lab virtually is that we have to do it at the same volume until we've gone past the equilibrium point. So we can't just like suddenly screw up and do it, like too fast, because that's one of the problems that we run into with these things is we get frustrated, we get tired of doing this, and we end up going way too fast, and we miss that equilibrium point. So this is one of the things I love about the virtual labs is we can't screw that up. So we're now going to go to the next phase. And what it's going to tell us is that order the steps for how you will determine the pKa of weak acid using the titration. So we need to look at the steps. Identify the volume of base required to reach the equivalence point. Calculate the volume of base required to reach the half equivalence point. Identify the pKa of the acid as the pH at the half equivalence point, and identify the pH at the half equivalence point. Okay. So I'm going to identify the volume of base to reach the equivalence point. That's first. Then I'll calculate the volume of base required to reach the half equivalence point. Then I will identify the pH at the half equivalence point. And then I will identify the pKa of the acid as the pH at the half equivalence So those are the 4 things that I'm gonna have to do. Because that makes sense to me. I need volume at the equivalence point, volume at the half equivalence point. I need the pH at the half equivalence point, and then I will be able to identify the pKa of the acid as the pH at the half equivalence point. So those are those 4 steps that I'll need. So my x-axis variable is going to be the volume of the NaOH added. I'm going to plot that against pH. That's going to be, well, actually, it's going to be a scatter plot. I'm going to create that, and that looks like this. It's a lovely little plot. And create that. I'm going to determine the pKa and record in the lab data. So this is my plot. And I think that my equivalence point is right in here. Which I can zoom in. So looks like it's right in here. An ish. And so that volume is roughly 18. I'm going to say 17 and a half. 18 and a half. So half of that. .75 is the one I'm looking for. So roughly there. And so my pH is just below 5. And so I need to look at the lab data. And I want to look at the weak acids reference. So this is what I need to look at to be able to determine that. I go ahead and do this. Get a screenshot of this. I'm going to copy this and put this into this over here. And what I see is that I've got chloroacetic acid at 2.85, hydrofluoric at 3.15, formic at 3.77, benzoic at 4.19, and acetic at 4.74. And again, looking at where I'm at, roughly here, we're closer to 5 than anything else. So I'm going to say it's 4.75. And therefore, it's acetic. And then save the graph. Do that. There. So we're going to try. Yes, look, I did it. Awesome. Now, it's very approximate. I don't like how approximate that is, but that's what I had to do, was to say, okay, it's roughly this. That's the volume there. My half volume is roughly this. Therefore, looking at the values that I had, it's got to be this one. Okay, so that's how we do that. All right, there are ways that we can make that more exact. And we talked a little bit in lecture about this, using that box diagram to get a more exact equivalence point, and then based on that exact equivalence point, the volume at that exact equivalence point, we can then get an exact volume for the half equivalence point, which can then tell us exactly what that pH is at the half equivalence point, which would give us a better estimate of what that acid is. But that was not required for this, so I'm going to go ahead and submit this. And we are done with this. Go ahead and stop here, and I'm going to stop this recording, and I will talk to you guys soon. All right.